is more important compared to the last two sessions, because here we are going to exactly talk about a touch point, what is DevOps, why DevOps, and how those services, those knowledge which you got from last two sessions, here exactly will help you, and why we focused a lot on those particular two sessions. So today, this is like a very important session where we'll club everything together. So with that, let me go ahead and start today's session. Just give me 1 second. Let me go ahead and share my screen. Is my screen visible? Is my screen visible?
Not right now, sir.
Is it visible now?
Yes, sir.
Can you see the first screen, right?
Yes, sir.
Okay, cool. So let's start with that. So as I said, the first session will be talking about today is getting started with DevOps on AWS. So you know me. I think this is the third session. Let me quickly touch about my introduction. So my name is Sanchit. I work as a lead architect at Quantify. Along with that, I'm an APN ambassador. I reach out. I try to interact with most of the people and majorly the students community, because they are the future of the industry. They are the one who's going to continue what we are currently building. So I always love to interact with them, help them from foundational career perspective, or maybe learning how to start their AWS journey and learn hands-on and all. So if you have any questions, any queries, any advice you need, you can reach out to me on LinkedIn, you can reach out to me on Twitter or GitHub. I'm available in all those kinds of stuff. Or you have my email ID also in the invitation, so you can reach out to me, drop an email. I'll be happy to answer them. Or if required, we can even have a call. So I'm happy to support you, help you guys in any way, any form you required. With that, let me start with today's session. Today we'll be talking about overview of DevOps. Let's first understand why exactly you need DevOps before we really jump and understand what is DevOps, what are the different AWS services, and how to enable it and other thing. Because it's very important that you learn why. Previously, this DevOps and all those cool modernized way of looking forward has all begun in very recent years, I would say. It's not this fundamental or this philosophy wasn't there. This philosophy was all there, but people were not really adapting into it. People started adapting to it very soon. I would say last 5-6 years when they started working on cloud. Majorly when they were on-premise, there were very few companies they were doing into the DevOps part of it. Now, what exactly was a traditional way? Before DevOps, how people used to work. Software industry is there from almost like 3-4 decades. So how people used to design the software or look forward around it, or what the need of DevOps were. So here, as you can see in this diagram, right? You have 3 programmers. Each programmer or each software developer is responsible for his own change. That's how generally people do, right? Now, what's new in it, or what's the problem in it? The problem that comes up is when they try to merge the code base into any sorts of code repository. Now, when I talk about code repository, I assume you guys already know things like GitHub, things like GitLab, or you talk about things like any sorts of any code repository where you store your code. Now, if you have 3 people trying to write into the same repository, for sure there is going to be a conflict. Some people may come up and say, sir, we can use branching. There is a different branch. Each developer can have a different branch. Sure, you can have different branch. But now, end of the day, let's say even if each of the developers create 3 different branch, you have to merge the branch into one master branch, because all this are 3 different functionality. For an example, if you talk about, let's say, any banking application, one is designing the login, second is designing the view, and third is designing to deposit. Now, this cannot be like a 3 different softwares. This needs to be clubbed into one package. End of the day, wherever you do it here at the last change, or do it on the code repository. You have to merge. Now, if you don't have proper branching and you have, let's say, the entire software build and then you try to merge, the problem is going to come up is there is a lots of conflict that will come up when you are merging it. 2, when it comes to testing, you will be having seriously lots of issues, lots of problem, because each one has designed their own logic way. They never even thought about or interacted with any other developer. Hey, what framework are you using? what language you're using. It may be even possible that they are using, let's say for an example, Java, but a different version of Java itself. Because they never interacted, never tested it out. They don't even know how much redundant code even they are writing. So it becomes a very huge, heavy package, which cannot be properly integrated and tested. And when it comes to testing, it fails. It severely fails. Because of that, your timeline to market, your entire cycle to again fix is very costly, and which reduce the overall delay. That was the foundational challenges which used to come. And thereby, if you just go and talk to any person who, let's say, was working in 1990s in software world, we always used to have a proper, like a huge book of project documentation, where they used to talk about the waterfall model, how we used to run the project and all in very sequential manner. All those things got completely changed from all sorts of directions in this entire new world of agile. There we will see in upcoming slide what is agile and DevOps and all. But this is the biggest problem, that when you, I mean, the whole idea is this traditional way was used to work, but it was not a form of synchronized way of looking around it, and not proper communication or feedback. That was a flaw in the traditional way of doing it. The second important problem that came that was there without DevOps is, like, as you can see in this memes, which I've got over the internet, someone is really trying to go sit and working in the production. It's equivalent you're taking a live wire and playing around it. Now, what are you going to impact? The outcome is going to be a short circuit, because you don't know, like, you're working in live production. It's like you're just playing around with any live wire of a bomb. If you just remove any wrong wire, and it's going to be a blast. If you remove a right wire, which is like 1 in a 99% chance, you will be survived. So it's that kind of a state, because you do not have any sorts of mature way of handling those things. So you always have to go play around with production, and the outcome is going to be a disaster. Like once in a 10 times you can say you will be saved, but then remaining 9 times it's going to be disaster, and you don't know. And then there comes up all sorts of nightmare. There's a production release. I have to be available throughout the night. I have 1 week I will lock down myself like in one room because I have a release and all. Those kinds of different things you will keep hearing from the people. Whenever you talk about any guy from software, I have a production release, I can't come. Why? Because that production release has become a trauma in everyone, because you're not following a proper DevOps lifecycle. If you have a proper practice of DevOps, proper testing, you won't even have that kind of a problem when it comes about production. I know there are certain things still comes up when it comes to production. It's not that easy how I put it out, but it's, you can reduce it, you can minimize the impact and pain of production. So that's what the biggest problem, the way developer used to work previously, which was not synchronized, not organized, versus the way there was completely lack of automation, lack of standardization, which was a biggest problem. And all those problems leads to overall delay in the business in terms of the time you can take that software in the market, the time you improve the quality of the software in the market. Those were the two problems where people commonly used to see before DevOps was in place. Now let's understand what exactly, if I summarize everything from a business perspective, this is what I've just created for you guys to understand the DevOps and all. But if I try to put it out like from a very business guys, from an industry perspective, if I use those terminology, the problem that comes up is lack of automated secure workflow. Lack of secure workflow in a business. So that's what we saw. If I talk about the first slide and the second slide, if you combine those two together, you see there was a lack of automation, lack of synchronization, lack of like a secure workflow management, that how you can ensure that everything what you're building is hitting the right way to do. And there you see this all problem comes into the place where building and maintaining the server, no environment management configuration, the deployment was very slow, the cycle was very slow, no proper ownership, right? And the last, if you see around those kinds of the 8 points, no proper configuration management, block deployments are blocker, production downtime, and hacking. So I know this becomes very difficult for you guys to correlate because it's come from a business perspective. But in overall, if you try to understand and summarize this, it just points 3 things: the management of the infrastructure, the management of the entire platform. That's one. 2, the time it takes to deploy anything in production. 3, the kind of ownership, the synchronization between the team, which we saw in the previous slide. And 4, the entire trauma I have to make the production release. These are the four biggest blocker for any business to run efficiently. And the impact they used to cause is you have to use, let's say if you can release a software or a product which can be done with 5 resources, you will need 10 resources. Misuse of capital in terms of you need 5 additional people to do it, plus the time you require to reach the market is more. That's why you're losing the business. Third, the same thing, the time which you require to reach in the market. And fourth, as I said, it's a very, people always feel fatigue. It's a laborsome process. It's very painful. So those are the couple of issues which comes from any organization perspective, that why they are always motivated to DevOps, because these are the 8 problems they face. Now again, someone will put out into their own words, but overall, these are the 8 buckets where their problem will reside. Any organization have a different way to express their pain points. Someone will put it out in their own words and all, but if you try to understand those 8 their pain points, it will fall into any of these 8 buckets. And overall, from a management or a business perspective, they will have into one of these 4 problems. So there exactly, organization always look forward some more seamless, automated, organized way to release something or to look out or to build something for the market. There exactly you see the DevOps came into the place. Now DevOps technically is not a one word. If you try to split into it, development and ops. So previously the problem which I was heavily emphasizing, synchronization. It's not that previously there were no people to do it. There were people to do it. There were same roles like site reliability engineers, release managers, operational guys. These are the same terminology, same designation, which was there in 90s also. But then what was the problem? What DevOps changed like all of a sudden? The biggest problem that was happening is this coordination and synchronization between the dev team and the ops team, which is the development team and the release and maintenance. So the person who used to release and maintain the production. There was a huge gap in terms of their coordination, communication, and synchronization. So development team always thinks I need to build something and that's what my job. Ops team always thinks from that shoe is that my responsibility is to maintain the production and deploy and maintain the production. Now, the dev team doesn't know how ops team is working. Ops team doesn't know how dev team is working. There was completely like a wall between both of them. That wall exactly DevOps broke. And DevOps is like, there is nothing like only development team, only ops team. Let's merge together. And they called us DevOps, where a person equivalently mature to build a software, as well equivalent have a knowledge and skills and expertise to deploy the software in production. That's why a person can understand end-to-end, and that's a major reason where you can see most of the organization in the market are looking for the DevOps person. Now DevOps, most of the people when they look out for job description or other stuff, they have a different perspective and skills to it. But an ideal DevOps candidate is a guy who can code very well, who can program very well, as well as who have very good sound knowledge of production deployment and troubleshooting. So any organization, any cloud which you look, these are the core fundamental of it, because DevOps is, if time comes, that person should also be equivalent enough to write the code in Python. Similarly, if time comes, that person should go into production and with proper hygiene, proper hypercare, they should be able to troubleshoot any issue in production. So there exactly the DevOps come into it, which is more a cultural change in any organization in terms of how they organize their team and have more proper way to run any stuff. That's one. The second thing that DevOps change outside the team structure is the way you work in a project. Now, previously, as I said, right, it was like a passing the parcel. Development team build something, they pass the parcel to ops team try to deploy. If it works, good for the organization. If it doesn't, again, it goes back to it. Now, the problem is there comes again, as there was no synchronization, the issue was still the same. No one knows why it failed or how I can fix it. There, DevOps brought up one more thing is the feedback loop. Now, as a company, or let's say if, as a developer, you build something, you build, test, release. Now, after test and release also, there is one more thing, which is plan and monitor. Now, you deploy it. That doesn't mean if it works for one day versus it works for like 10 years. There is a gap in it. So how exactly you can ensure that whatever you build works minimum for 10 years? There you plan and monitor. It's always that you learn and you evolve. So now how are you going to evolve? When you measure that how your software is performing, you see how people are using and you learn from it. So that feedback loop also DevOps added into it. And that's how people very easily start adapting to DevOps, because the way it start giving the business outcome to it, the improvement in the production, the improvement in the efficiency, that's how people started adapting the DevOps. And then there is a framework on which the DevOps was designed, which is CLAMS framework: culture, automation, learn, lean, measurements, and sharing. Culture, as I said, you change the way your project team works, more of a product team. And there is nothing like development pure, nothing like ops. There is mix of people that looks forward, like cross team, cross skills. Automation, have proper automation, programming skills, AWS services, those kinds of automation. Lean is you follow that process which you have properly around that. Measurement is you measure, monitor, like what are the changes, has been done. You monitor it properly, so you learn and you get a feedback. And at the last, collaborate and share. Like it's very important at the end of the day that even how good you are, but each project offers some kind of a sharing, and that sharing is what something you should spread across your organization. So in another project, maybe on similar lines or on higher complexity, you learn, you implement the values which you have explored from this particular. So sharing retrospective is very important. So that's all DevOps is. It's nothing kind of like a technology or something. It's more a cultural change which every organization should do, which help them to work efficiently. So that's about the DevOps. And again, just a quick reminder, if you have any other queries, any other questions, please unmute yourself and ask me. This is very important session and it will help you a lot from your placement perspective. Moving towards the next, how exactly the DevOps cycle look like? Now we understood that, okay, if you go first, who are working on it. So in development team, you have the code repository, you have the entire build, testing, then the compile, deploy, and monitor logging. Ideally, there is no change. If I talk about this, up to from development to code deploy was already happening previously also. If I talk about any era, 1980s, 1990s, all those softwares were built in the same fashion. There was nothing new. Like someone used to have an automated way of building it, like with shell script, Python script. Someone used to manually do it. So there was already a way to do that. The only thing, two things which DevOps has added new in this cycle was monitor and logging, that you measure how are you doing. And second is this feedback loop, that whatever you measure and monitor, you send it back to development team that, okay, the software is working fine, but the performance is not up to the mark. Or maybe let's say the customer performance is good, but customer still feels that a couple of features are missing. Let's say for a very example, very simple, you're building, you're designing a banking software. In that software, you given all the functionality to user to create account, to make some payment, to remove, I mean, to make, to deposit a payment, to withdraw payment, but you forgot to give the view payment. Now that's a very core feature. And you release the entire software with 3 functionality, and customer is always looking forward. I don't know how I can view my payment. Like I deposited, let's say 5,000 rupees, but did it enter into my account or not? How do I know? And that functionality is missing. But if you don't measure and monitor, how do you know that customer is looking for that functionality? And end of the day, what will happen? He will stop using your software or stop using your website. He might go to some other bank or some other software. So that's why it's very important that you understand the need and the ask of your customer, and the customer can be anyone, your internal employees or your external public ones, external employees or external customer. You understand, measure their ask, monitor their ask, and apply that feedback back to the development team. 2, what are the processes? We understood in the previous slide about the framework, the different jargons, but what are the DevOps practices that any organization should adopt or inherit it? So first is infrastructure as a code, microservices, continuous integration, continuous deployment, communication and collaboration, monitoring and logging. Now, if you go back and remember my slide 2, where people were really working in a live production, like how they have a live wire in their hand, and if they make any mistake, it's all over the place. Similarly, the reason of that is because you don't have a proper automation strategy. You don't know how things have been deployed, neither you have any idea. You manually take a screwdriver. It's just like you're taking a screwdriver and putting it into a live server. And then you're going to get a shock. So that's kind of stuff. Two, microservices. What exactly is a microservices? Microservices means whatever you build in a very small unit as possible. Now, when you talk about any sort, continue the same banking example, what you have is you have like select, you have create, retrieve, update, delete, right? That's what we do any sort of database operation. Microservice means you do only one thing at a time. Don't create a kind of a service which does all four things. The problem is if something goes wrong, then when it comes to reverting that change is very difficult. So rather than making all those four APIs under one code base, try to make it microservice. And there we understood in Lambda. When we were working in the Lambda, we really understood that how exactly you make one thing that function as a service, which we understood in Lambda. That's exactly what cloud promotes or DevOps promotes, that you have microservice. The remaining 2 points, continuous integration and continuous deployment. That's exactly what we saw in our first slide. Don't wait for any changes. If you feel that you have made a change, deliver that change. That change may work or it may fail. That's a secondary thing, but deliver that change. So any next person which is working on that integrates and work on top of it rather than waiting for like 6 months and 9 months and then one day you identify that you both are been overlapping completely on each other. So continuous integration. Fourth point, continuous deployment. So by default, if you follow continuous integration, you also need to deploy those changes. Just putting those changes into your code repository will not help unless and until you put that changes into your production and see how that how that functionality is working live. Communication and collaboration. As I said, DevOps lives on the principle of communication and collaboration. Communication and collaboration in terms of your customers and your entire technology team. Communication and collaboration in terms of your dev and the ops team. So that's very important. And last, measure and monitor. Monitor and logging. Monitor how your system is performing. Log what your system is doing. These are the two things are very important that will help you from a feedback loop perspective. So these are the DevOps practices. And again, don't worry about it. It's all going on my head. I can't understand. It's all of these things. What I'm explaining you guys, we'll do a demo before in today's session. So you will understand what I'm talking about, everything. Now, what do you get as an impact? The impact, I think it's pretty easy to understand by now. High speed operation, rapid delivery, increased reliability, high scalability, enhanced security, and better collaboration. Now, if I talk about everything, in short, if I summarize it, it all ensure that you reach out to the market very fast. You have a proper synchronization within your team. It's cost effective. The security and the kind of reliability and scalability which you require for your system, that it should be highly reliable. It should scale, let's say in multi-AZ and all, and it's properly secured. DevOps Pro with help of proper testing and proper collaboration. So that's why, or where exactly DevOps help exactly on the ground. If I keep all the theory language in aside, but this is how DevOps work day in, day out in any project. Any questions here? Okay, cool. Moving towards next. Let's understand how exactly the DevOps cycle, the cycle which we talk about here, can look like an AWS landscape. So this exactly is the AWS landscape of DevOps. AWS itself provide services for code repository in terms of collaboration and communication, in terms of continuous integration and continuous deployment. So these are the three services. This is for collaboration, which is like how you have your GitHub, GitLab, Bitbucket, any sorts of code repository. AWS also provides their own code repository called as code commit. This is for continuous integration, which is code build. And this is for continuous deployment, which is code deploy. And this entire pipeline is like a package, a visual workflow that help you to understand and monitor how this is happening, like how each stage is going and how your entire the continuous integration and continuous deployment pipeline look like as a visual workflow. So that's about how exactly AWS. Now, as a deployment, from a deployment perspective, you can target multiple of services. Like here, as I mentioned, you can target EC2, container service, Lambda, You can deploy CloudFormation, ops work. You can also have config to monitor the state of the pipeline. You can have multiple service from a deployment perspective, as well as you can have multiple other services to measure and monitor. Measure, like as I talk about config, CloudWatch, CloudTrail. These are the services which you can measure, which help you to measure and monitor. And from a deployment perspective, you can use most of the services which you always use day in, day out. And with help of CloudFormation, it becomes, I mean, you guys can easily understand because we understood in our second session itself that how exactly CloudFormation is very important, what different things you can do. And CloudFormation also is one of you can use as a deployment. So that's why it was very important for me to walk you through first the serverless and the CloudFormation before you go into this thing, because the DevOps, the core important thumb rule or the core fundamental thing to implement DevOps is the automation. Infrastructure is the code, and the another automation is the Lambda for microservices. Now, how this workflow works, right, in a real life. There is a developer, or there is a single developer or developers. Whenever they make a change, let's say they are making any small changes. At the end of each change, they put their code into the GitHub, or you can think of code commit. When you're configuring the code commit, you have multiple ways to do, like an auto time, real time trigger, or you can trigger it manually trigger. That's on you how you want to define. Let's say we define it auto trigger. So as and when a developer push a code into code commit, the code commit changes have been triggering the code build. So code commit by default, whenever you make a change, it goes to code build. Code build downloads the code, tests the code, package the code, and then that package code goes into the S3. And the package code, you can think of anything like your .pyc file, the compiled Python file, jar files, any deployable package. That's what you can think of. And the code deploy takes that artifact, which we called as an artifact. The compiled outcome is called as an artifact. Takes that artifact and deploys that artifact into any of the code deploy platform, which can be EC2, which can be CloudFormation or any other stuff. And this all works in very synchronized with help of code pipeline with visual workflow and without any sorts of click in a real-time fashion. If you deploy auto trigger in your code commit, so that ensures you not only properly deliver the changes into code commit, you thoroughly integrate, continuous integrate with thorough testing and other details. And at the last, you have a continuous deployment by releasing those new changes what you have developed. So that's how the DevOps cycle works when you talk about the AWS fashion. And this is exactly what we will be demoing today. But before that, let me quickly talk about a couple of DevOps services. So you guys can understand, or someone ask you that, okay, hey, what are the services outside DevOps, right? How exactly AWS provides different services or different categories. If you learn in the DevOps practices, and if you want to enable DevOps practice in an organization, how you could do it, what are the different services? So let's quickly talk about those technology stack for DevOps, a couple of quick slides about each services, and then we will look forward towards our demo. So talking about from a continuous integration, continuous delivery perspective or deployment, this is the 4 services what AWS provide: code commit, code build, code deploy, and code pipeline. We just understood in the previous slide about it. Second is infrastructure and automation, like anything which you want to deploy, let's say EC2 instance or Lambda. I assume you guys already know about infrastructure automation by now. Infrastructure as a code, which we saw in the last session itself. So you have different options: AWS CloudFormation, Ops Work, System Manager, Code Deploy. Most probably people are heavily relying on CloudFormation and then Code Deploy. I know Code Deploy will be looking forward today in session, but CloudFormation, you guys have done a pretty much hands-on. You have all the required knowledge there. Monitoring and security, there are ample amount of tools available for monitoring and security. If I talk about very core ones are CloudWatch, CloudTrail. Those are the one which is help for monitoring and logging. X-ray in terms of your performance, that how your application is performing. Let's say how much time it takes to download a file from S3, or how much time it takes to, let's say, read a record from database from performance measurement perspective. Config in terms of for the compliance. If there is any change in the state of any resources, then config can help you. And rest of the other services are more from a security perspective. Last, platform as a service. So DevOps, you do CI/CD, you do automation, you do monitoring and security. There has to be some platform, right, on which you do it. So what is that platform? That platform is Lambda, the serverless which we saw in the first session. We heavily touch base about how serverless, why serverless, different features and demos and all. Elastic Beanstalk, I think a couple of them people already know Beanstalk because they have done a cloud practitioner. It's an platform as a service under that. Beanstalk, ECS, EKS, and Fargate. These are three container services. The first two are container as type EC2, and this is serverless. Again, these three all part of the containerization services. First two are like an EC2, and the third one is the serverless container services. So that's about AWS when you talk about the four different pillars: CI/CD, automation, monitoring, logging, and platform as a service. There, AWS provides different kinds of services to help you to achieve the entire DevOps within your organization in a very cloud native way and with a pay-as-you-go model. Now let's quickly understand a couple of services in detail. So starting with the core important one, continuous integration and continuous delivery, where we have three major services: code commit, code build, and code pipeline. Code commit. So code commit, if I talk about in simple, as I said, it's similar to how you have any sorts of GitHub repository, any sorts of GitLab or any code repository. The benefits remain the same. You can have versioning, you can have collaboration, you can have security, you can have real-time alerts, notification if someone makes some change, or you can integrate with the any sorts of any DevOps pipeline, not just AWS native. You can also use Jenkins, which is the another widely used CI/CD platform in the market. So you can use that similarly how you use GitHub. The other benefits of, as I talk about, right, fully managed, like the best part of code commit is it's like fully managed. AWS takes care of it. That's one. Two, you don't need an additional username and password. It's fully integrated with AWS native IAM. So if you have set up like say IAM policy for any user, with that IAM itself, you can take care of everything. So that's the best part, that from a maintaining of other softwares and all when it comes to code commit. And again, it's managed service of AWS, so it's highly available, it's durable, and it can provide all other kinds of notification and other thing. So that's about code commit, but I would say very simple if you want to remember it. I mean, you don't have to go to very detailed like features, benefits and all. This is for more from a knowledge idea perspective, why people are using and all. But at the bottom, the more important thing to focus here is code commit is exactly the same what you can think like other GitHub, GitLab, big bucket kind of repository. The advantages is fully managed by AWS. And third, it can integrate with AWS identity and access management. So you don't have to worry about setting up the new user policies, password and all. These are the three things you have to remember about code commit. Next, code build. Now code build, as I said, is a service which help you from a continuous integration perspective. Now continuous integration perspective, there you can see this code build, code pipeline, code build, code pipeline, code deploy. There is another open source offering is also available in the market called as Jenkins, which also does the same thing. The problem with Jenkins, I mean, I have used extensive Jenkins as well as the services. Now in the code pipeline, in the code build also you can use Jenkins, by the way, for building the software. But the advantage of using code build is, again, it's a managed services. So you don't have to worry about spinning an EC2 instance, providing the VPC security, hardening it, managing the AMIs and all. You don't have to worry about all the stuff. You only worry about writing good application and writing good testing that you can test in code build. Infrastructure wise, AWS takes care. And again, it not only takes care, it closely integrates with CloudWatch and other kinds of monitoring feedback. So you can observe how are you doing in terms of building the software and how exactly your software is behaving or performing when it comes to the testing. That's the big advantage of using code build compared to other softwares in the market. So as I talk about, if you talk about the key benefits, fully managed, continuous scale, pay as you go, and extensible. That's what I said. When you talk about managed services, these are the benefits when you easily get from any sorts of managed services. So that's about code build. Again, we have finished code commit, code build, and the last is the code pipeline. Code pipeline, the major job of code pipeline is to give the visual interface or visual workflow. It underneath uses the same code commit, code build, code deploy, those three services, but it helps you to give a visual workflow and help you to understand how things have been doing. So end of the day, if you want to trigger like a chain, that first, whenever a developer makes any changes in the GitHub or any sorts of code repository, it should trigger a code build, and code build should should code deploy or cloud formation. That all is taken care by code pipeline. Code pipeline connects all those different services as one synchronized workflow. So that's about code pipeline, and advantage is again the same. Serverless zero, I mean, you don't have to do any administration. It is very completely managed. We'll see in the demo. You just have to provide the right configuration and everything taken care. Rapid development. You can also automate it, configure it, customize it, the entire workflow with help of the Python script, CloudFormation and all. And then last is easy to integrate. I mean, for demo purpose, I will intentionally use GitHub repository. You will see it's very easy to integrate not only with AWS services, even with GitHub. Like in 2 clicks, you can easily integrate the GitHub, provide the token and for webhook, and it will be done. So it's very managed, very simple. You don't have to worry about patching the software the patching the OS where the software is running, scaling it out. Everything is taken care by AWS. You just have to follow the proper configuration. That's the end. The first 3 services, which was heavily talking about from a continuous integration and continuous delivery perspective. Now we'll be talking about the infrastructure and automation. Now, infrastructure and automation perspective, you can use CloudFormation. There are other services, as we saw in the previous slide. OpsWorks is there, and OpsWorks and all those things. Now, OpsWorks is very complex another way. But if I talk about what you need as today in the market, like the starting for start is the CloudFormation and the code deploy. CloudFormation, I can quickly cover infrastructure as a code. You guys already saw, understood in the last session. You do not pay any charges for CloudFormation, but you pay for the charges of the resources which are getting deployed by the CloudFormation, and it helps you to automate document of your infrastructure. And if you design your infrastructure very well, that code can be very generic and you can use across regions, across account. So that's about CloudFormation. And again, if you want to understand in detail how to write CloudFormation and all, I would request please go back to my previous session, which is already recorded, and understand in detail what is exactly CloudFormation. And again, it's very important service from an infrastructure and automation perspective. Second is a code deploy. Generally, people always use code deploy under continuous integration and continuous delivery. Intentionally, I have brought code deploy under automation because it helps you to automate the deployment part of it. CloudFormation helps from infrastructure provisioning or configuration. But if you want to automate the deployment after every change, not the first time, every time, whenever you make a change and you want to automate that process, then code deploy is the service. And this demo will do the one-time change versus the ongoing change. That will understand around the difference. But code deploy helps from it's again, you can think under CI/CD or automation, that's fine. But the core benefit of using code deploy is it helps you to automate the entire deployment part of it. Deployment across different services, different stack with proper control, proper security. So that's more about the code deploy part of it. And again, the key benefits are centralized control, automated deployment, minimized downtime, and easy to adopt. As I was talking about, it's a very simple, it has like a very simple YAML file where you talk about the steps, which you call it as app spec. And in case of code build, you have a build spec. I forgot to add that. In code build, you use a YAML file called as build spec, and code deploy, you have app spec, which we will look into the demo part. There you deploy what you need, what are the different stages, and it's very easy. With few clicks, not more than 10 clicks, you will be all good to have code deploy up and running. The next is the monitoring and security, CloudWatch, CloudTrail, and config. CloudWatch, I assume all you guys know what is CloudWatch for monitoring, for logging, for alerts, for events, any sorts of schedule. CloudWatch plays a very significant and core foundational role. It can integrate with any services in terms of monitoring and logging, right? So if you have any sorts of performance feedback, anything which you need, anything which you want to log, CloudWatch is the best thing. It's highly scalable, managed services. You don't have to do anything. By default, CloudWatch takes care of all those kinds of stuff. You just have to enable by deploying the agent. If you want exhaustive logging, then you need to deploy the agent. In case of basic, that also you don't have to do. It by default provide that. So that's about the CloudWatch. And again, if you have any questions or queries, please don't wait at the end. Ask me now itself as we are going through these different services. So if I need to recap something, it will be easy for you. Next is the Cloud Trail. Most of the people always get confused between CloudWatch and Cloud Trail. CloudWatch, do remember, it's for logging and monitoring for the services. Cloud Trail is more specifically from a governance perspective. Who are the users who fired the API? Let's say if someone terminates an EC2 instance. Now, who was the user who fired an API to terminate the EC2 instance? Who was the user who deleted the cloud formation? So those kinds of API calls and the tracking of API calls is done with help of Cloud Trail, right? So don't get confused in CloudWatch and Cloud Trail. Any certification exam you talk about or any interview you talk about in DevOps, people always, this is a very foundation, people always get confused between both of these services. So do remember that. And again, you can capture all the APIs and everything, and you can log it back to CloudWatch also. You can integrate CloudTrail to CloudWatch logs, and whatever the information gets captured as a part of CloudTrail, you can put it into CloudWatch, and CloudWatch becomes your central repository for any sorts of logs. You can enable that, but do remember, CloudTrail is completely different. It used for tracking all the APIs and the person who fired the APIs or which IAM role or user, whereas CloudWatch is completely different. It is for logging and monitoring. Okay, so that's about the CloudTrail. Any questions? Next is the config. Now, when you talk about any IT industry or any customer, when you start working as a cloud engineer or as a DevOps engineer, most of the people wants to have a proper compliance. Let's say if you make some changes in any of the AWS services, they want to track those changes from a compliance perspective. Who did it, when it was done, why it was done, who given approve. I mean, this is all required to compliance from perspective, right? Their config is the right service from a compliance perspective. It helps you to monitor any changes in the configuration. Very simple example. If let's say you change the timeout of Lambda, you understood in the first session we talk about the timeout of the Lambda, right? If you change the timeout of the Lambda, that also will get preserved in config. Let's say you make it from 30 seconds to 1 minute, that all things get tracked under config if you enable it for the service. And then you can do any kind of stuff. Let's say for a very example, someone opens a port at 00, which means anyone can access from external world. If you have that kind of 00 kind of stuff and you want to delete those kinds of rules, that also you can easily do it with help of config. So config, do remember, from a compliance perspective, to preserve any configuration change, it helps you. Next is a platform as a service, right? Platform as a service, end of the day, is like what are the different platform where you can have the CI/CD tool operate on, like what should be your destination or target. So these are the couple of services from target perspective. Lambda, Elastic Beanstalk, ECS, or if I simply put it on, the entire containerization services. Lambda, serverless services, managed services can easily with, I mean, simple, you just only have to focus as a code. You don't have to worry about the infrastructure, and it can all automatically scale and all. I think we have a very thorough session, our session number 1 about Lambda. So I'll skip, I won't go in much detail. We have already talked about a lot about Lambda. Beanstalk as I talk about platform as a service. Let's say if you have any Tomcat, any sorts of web server, any API based kind of thing where you really don't want to worry about patching or how things all works on OS. It's a standard web service which can easily deploy in Tomcat and all. And you want to deploy, then Beanstalk is go-to service. It provides different web servers like .NET, .NET is there. You also have Python in it. You also have Docker you can install. You can use Tomcat. Those kinds of different web services and Docker, you can set up your application without really worrying about the core infrastructure. And this falls in the platform as a service category. And again, the best part about using Beanstalk, it simplifies and provides multiple best practices. Like best practice in terms of when you talk about deployment, right? The way you release any software in production, that's called as deployment. There are multiple types of deployment. Are there in place, blue, green. Beanstalk helps to also promote that best practices also, that what different types of deployment you should do. That's why most of the people always try to see even Beanstalk. But again, Beanstalk used to be used, but many people now even are looking forward from container services. So container services, ECS, you talk about the container where AWS is the only cloud which provides plain Docker as under container services, or you talk about Kubernetes, Amazon EKS, Amazon Elastic Kubernetes as a service. Those are the two major services in terms of the entire containerization part of it. There AWS also offers, if you want to run ECS or EKS as a serverless mode, then that is called as Fargate. Fargate is the serverless offering of AWS in the containerization, which can be an ECS also, which can be an EKS. The benefits is you can do all the sorts of best practices, blue-green deployment, the proper scaling, the proper automation, proper testing, rollback, all sorts of features and functionality which is required. It very easily handled when you use containerization service, whether it's ECS or EKS. Next, let's understand. I talk about the different services, but what are the tools as a developer you need, right? You also need certain tools. Code commit we already talk about as one tool, but you also need some tools to interact with the CI/CD pipeline, to build a CI/CD pipeline, to interact with AWS services. So what are those three tools? Three tools are Cloud Shell, SDK, and CLI. So SDK is like a software development kit, like you talk about JavaScript, Python, PHP, .NET, Ruby. Like there is many services what you have, right? Almost there are 9 services which AWS provides as an SDK, and you can. There is one more which is called as Rust. It's a new thing. I think I am pretty sure you guys will not have heard about it. So totally there are 10 different kinds of SDKs AWS provides to provide a developer friendly environment that whichever programming language you come from, it doesn't become a barrier for you to write the code in it. So that's become SDK. And again, the whole idea of SDK is it allows you to interact with different AWS services using any of these packages built in any of this programming language. So you come from .NET, you come from Ruby, you come from Go, or you come from Python, JavaScript, Node.js. If you want to interact with AWS services, AWS offers their packages, their APIs that you can interact with the services. Again, the example of SDK, if you guys have worked on AWS in some form, some shape, Boto 3. Boto 3 is a Python SDK, which is widely used, whether you are a machine learning engineer, a software engineer, or a platform, or DevOps, or a cloud engineer. Boto 3 is widely used. If you really don't know about Boto 3, then you have to really go back and understand AWS. But it's that famous and that widely adopted across the market. So as you can see an example that you have to install the SDK, then you can directly import the SDK and you can perform any action which you want to do. Similarly, how you do in your Java, right? You have your Java library, then you do import Java, and then you use that any sorts of methods and functions provided by that particular library. So same is what the SDK works. It's a generic concept. It has nothing to do with AWS, just that this SDK is designed for an AWS specific API calls, but it remains the same. And if someone really wants to get to core of how the Boto 3 and other thing, it's pretty new, then I've given a reference link here. This will help you to directly point to the documentation, which has for all, I mean, this documentation is very exhaustive and it talks about all the different services, not only the services, the different features and configuration that's required within that service. So the best thing, if you ever want to work on Boto 3, you don't need any reference code and all. This documentation is the best in class. Follow this documentation and you can solve anything. Cloud Shell. Cloud Shell is most of the time you use command line and other stuff where most of the people coming from Windows system, like I have Mac, someone may have Linux, Ubuntu. For them, it's become very easy to do in a command line kind of thing. Most of the time, they always interact with command line. So for them, it becomes very easy. But the people, when generally they comes out from a Windows system, sometimes it becomes very difficult for them because of PowerShell, the CMD and all, lots of hustle. That AWS remove that hustle itself by putting a command line interface kind of tool at no cost in AWS console itself. Directly from your browser, you can directly invoke Cloud Shell and you can do anything. I'll show a demonstration also today. You can directly just with one single click, you have that Cloud Shell open, you set up anything, you play around, and that becomes your virtual, your local, a mini workspace itself on AWS you can think of. And again, the best part is you don't have to worry about, as Point mentioned, it's pre-authenticated with your console. So since, as I said, this particular Cloud Shell is already part of AWS console, You don't have to worry about playing with the access key, secret key, IAM roles and all. It by default out of the box authenticate and then gives you the command line. So you just simply have to focus about what you need to write or why are you using this Cloud Shell. Don't worry about the authentication and all, which Cloud Shell handles it behind the scene. CLI. CLI is like command interface. Let's say someone comes up and say, I am not good with SDK. Like I'm very beginner. I don't know with SDK, but still I want to work on AWS. One way is you can go on UI and do it, but my company does not allow me to UI. Most of the 90% of the company doesn't allow you to access UI. Then how I can do it? The another way is CLI. Now if you know the command line commands, then also you can write even if you're not a programmer and if you just want to work with AWS, then you can use the command line commands and you can take care of that. So those are the different AWS CLI that it offers. We'll look at the CLI in the Cloud Shell demonstration where you can play around with any of the AWS services from command line itself. Many times I've seen customer even or the developers even use CLI commands in the cloud formation to automate. Like if they don't come with, let's say, any programming or they hate programming, then you can also use CLI and put it into shell script or a bash script, and you can use that bash script as a user data or any sorts of automation. So that's also one of the pattern I've seen in the market. An example, as you can see, you first download this particular stuff, then you do version, and then you can do any sorts of operation as given in this example. And again, if you guys want similarly how Boto, if you want to understand the different feature, different commands, different features of CLI, you can point to this hyperlink. It will help you from understanding. That's what we have understood so far about DevOps. It's been last 1 hour. We are all talking about DevOps, why DevOps, what DevOps, how it can help, what are the different AWS services, AWS offering, and all those kinds of good stuff. I'll take a pause for 2 minutes. I'm open for any sorts of questions you guys have before we go to the demo. Please unmute yourself and let me know if you have any questions. If you don't have any questions, then I'll go for the demo. If you have any, then let's interact about if you have any questions around that.
Hello, sir.
Hello.
For any reasons, I don't want to use AWS pipeline. Instead, I want to use GitHub as the development repo, but I do want to use other AWS services. So is that integration possible in AWS?
Yes, that's exactly what I will be demoing it. I won't use AWS code commit of AWS. I will use GitHub and I will use the AWS services for CI/CD. That's exactly what I will be doing in my demo today. Hope that answers your question, right?
Yes, sir. Yes.
Any other question, guys? Okay, cool. I think we are good. I hope it's very early morning for you, so you guys are still in sleep mode, or I am teaching it very good. That's fine. In any case, let's move on and let's go towards the demo part. What I'll do is I'll just stop the presentation mode. Again, I would request everyone here on the today's session, please go ahead and perform this demo. I will give you all the code script which is required. The instruction I've already given in the slide, which I will share with you guys. Please go and perform this demo. This demo will help you to get to the very core understanding how exactly the AWS services works. Okay. So I think someone asked me that, okay, I want to use the GitHub, not code commit and all. So first of all, let me walk you through each steps. This demo will need like around 20 to 25 minutes. And I'll walk you through each and every steps in detail. So please focus now. So this is the architecture what we will be deploying. Now you can use Cloud9. Cloud9 is something like you can talk about your Sublime, your Eclipse, or Visual Studio, the code editor where you can write the code. Technically, I already have code developed, so we are fine. We can skip the Cloud9, but you can also think Cloud9 as an AWS editor, which AWS offers natively. We don't need this, so we are fine. Now here exactly what we will be looking. We have code commit, we have code deploy, code build, code deploy, and there are certain configuration which is stored in parameter store, which is the best practice to do. A visual workflow code pipeline, which will be deploying an Nginx, a kind of a node code in the EC2 instance, and have a load balancer on top of it. And this entire thing, outside deploying the pipeline, this entire the EC2 instance, the private public subnet, the VPC, the load balancer, all I have automated it. So we can purely focus like anything like VPC, IAM, EC2, ALB, that all have automated via CloudFormation, which CloudFormation is also in the GitHub repository. We will be corely focusing on how to set up this all three, and I mean all these three things, like code build, code deploy, and code pipeline. And again, this code deploy also I've given how you should do it as an optional at the last. But if you, I will more focus on GitHub because code commit is like very natively available and it's very simple to do. Most of the people always look into code commit. But even if you want to do something else with code, GitHub and all, then how you can do it. So we'll focus on the GitHub. So with that, first, let me do one thing is let me go ahead and put the CloudFormation on the deployment mode. It will take like good amount of time. So again, as I said, you guys are very much familiar around how to deploy the CloudFormation, what is CloudFormation and all. I've designed the template in YAML. This CloudFormation template will deploy your entire VPC for public private subnet, the security group, like the entire VPC, what's required. This entire VPC required, this public subnet, private subnet, EC2 instance, ALB, and the IAM roles which is required for performing this lab. So it will do all the sorts of prerequisites. I'll quickly go ahead and put this into deployment mode. Again, I'm doing it in a fast scale because we have already covered up how exactly the CloudFormation works and all in the last session, which was last Saturday. So if you have any other questions around how this works, please go back to that session before you perform this demo. This demo, this entire CloudFormation will take like around 10 minutes because we are setting up too many resources around it. So in meantime, let's go back. Now, the second thing is I have my GitHub repository. This is my private GitHub repository, which I've created for this demo. This has all the kinds of scripts which is required. My application, my deployment is the CloudFormation, any additional scripts which is required, right, for code deploy perspective. And the important thing which I want to walk you guys through is this two files, app spec, build spec. Build spec is the file which is required for building. When you're performing a build, what exactly are the phase? So as you can see under phase, first you talk about the environment, which if you go back in the architecture diagram, you see that there is a parameter store the code builder is reading. So what exactly this parameter, what value this code builder is reading from this parameter store? So this is a value where you can see AWS region. To make it dynamic, it is reading an AWS region. Again, you can have different ways to do it, more from a best practice or how people work in industry. I want to give you that exposure. That's why I've used parameter store. But again, AWS region is something you can take it from anywhere, not just parameter store. So environment you can take, or any configuration you can take from parameter store. Then these are the build phase. Install, build, install whatever you required, and then you perform the build. And at the last, whatever the build artifacts are, these are the artifacts where you mark them with the name, date, time, month, year, seconds, right? So you tag that artifact. If you want to go back, roll back to the previous version, it becomes very easy. So this is the structure of build file. This is written in a YAML format. Okay. Next, we will understand. And again, as I said, build. So it will be used in a code build service. App spec is application specification, which is used for the code deploy when you're deploying it. This includes everything, things such as all the different deployment activities. Now, as I said, code deploy is used from an automation perspective for the deployment. It may be also possible that application is already running and you want to release one more new version on top of it, or you're releasing for the first time. So any sorts of prerequisites, or you talk about, let's say, stopping the previous application, then deploying and then running. All those different kinds of are called as hooks. like different life cycle, different stages in the life cycle. As you can see, after install, application start, application stop, those all kinds of stuff is called as a hook or the part of a life cycle. So there you talk about all the details which is required from a deployment perspective. After install, application start, application stop, and each of these steps you can provide a shell script. So in this shell script, so you don't need to provide the exact command in this abstract file itself. You provide a location of your shell script, and that location of this shell script, all the scripts are pointing to this one. Like here exactly you're doing all the prerequisites. We are installing npm install. Here you perform that, okay, if you already have an existing software running same version of node, you kill that. And if you want to start npm start around this one. So that's exactly how you can do around the app spec and build spec. It's more important that if you want to work with the services, ideally, first you need to understand how to configure the services. Second most thing which you required is these two files. Build code from code build perspective, build spec, from an apps perspective, from code deploy perspective, app spec. Again, the documentation of AWS is very, very exhaustive, very good for both of this file. So do follow the AWS documentation. If you want to build more extensive and more good demo, what I have done as a base, you can take that base and you can extend it, right? This, I will give the link of this repository. I will make it public and give it to you guys after the demo. Feel free to subscribe to this repository. Feel free to create a pull request or fork this repository in your own and try to build something. But before trying to modify any changes, I would highly request try to replicate the one demonstration which I'm walking you through, so you will understand in detail how it works. Now let me go back and see, is the CloudFormation stack ready? I think it's not yet there, but it has deployed multiple of resources. Let's wait. I think it should take few more minutes by that time. So in meantime, what we'll do is, right? Oh, yeah, it is done. So right time. So as we can see, this CloudFormation stack is completed. And if I go back here, it has created in the resources section, it has created all the resources for the load balancer, all the code build role, code deploy role, the SSM parameters, the EC2 instance. It's launching EC2 for our web server as well as the jump server. Any sorts of IAM you need, elastic IPs you need, internet gateway, NAT gateway, and a route table and all. So this is the complete VPC. So this save this repository because it will help you a lot in your IT industry also. This CloudFormation does everything. Set up the entire VPC landscape from scratch end to end, and then deploy a kind of web server, a jumps host, a load balancer on of it, which will help you. This exactly is the blueprint how generally people work in industry when they talk about deploying web servers. They don't deploy like in a public subnet and all. They deploy in this similar fashion. So do save this repository. I'll give the link to Mayur post this session. So this about the entire prerequisites. Now, next what we will do is, if I go back to the presentation, step one was, okay, first you have all the key files for EC2 instance and all. I'm pretty sure I do have it. So I've done it. Again, you do not need to name. Just do remember, you don't have to use the same name. Use the name which you already have. If you don't have anything, you're doing it for the first time, then follow as is same name, same thing, what I've given. Don't try to play around with it for the first time. So we have done the key pair. We have done all the CloudFormation part of it. We have deployed the stack, and we can see under the output section, there is a load balancer link. Now, if I put this load balancer link, it will give me an error 50 bad gateway. Why? Because I have just deployed the infrastructure. I don't have any application running. Okay. So that's about step one. Step two, let's validate the configuration, the EC2 which we have deployed. We need two important things in that EC2 instance. Code deploy agent should be running in it, and Node.js should be running. Again, I have not automated it because I want to demonstrate to you a couple of more utilities of AWS. If you're very good in AWS, you can do everything with the help of CloudFormation itself. So as I was talking about, you can, when you talk about doing an SSH or going into the server, most of the people, they use PuTTY, they use Mobaxterm based on the operating system you're using. But most of the people also miss that you have to provide key files and all. Let's say I don't want to provide key files. I don't want to do anything. I want to directly from AWS console itself log in into an EC2 instance or private server. How I can do that? So for that, you have something called a session manager. Under SSM parameter, SSM system manager, there is something called a session manager. It's one of the offering. And for that, you don't have to do anything. Just provide the right IAM role, which I've already given in the cloud formation. So now we will see I've select the EC2 instance. I click on connect, session manager. And as you can see, connect using session manager, and it is already given. What do you need here? Okay, and then I click on connect. So this is I'm inside the EC2 instance B25. With just few seconds, I'm EC2 instance without providing any IAM, without providing any sorts of PEM file, any sorts of security group and all. With a fraction of second, I'm there in the session manager. So it's a very secure way, and most of the you should always look forward in this fashion. Now, as a step 2, we talk about we have to set up the code deploy. So let me check, is the code deploy already exist? Yes, it does exist. Let me check, is the node already exists? No, node is not there. So what we will do is we'll try to deploy node. So commands I've already given in the presentation. You don't have to Google or do anything. You just have to copy paste these commands, how I'm doing it now. Okay, you have to copy, run all these commands. 1 second, let me copy it properly. Okay, so as you can see, the Node.js installation started. It should take like a few minutes to. Okay, and now let me run this command again, npm-v, which should give me the version of npm. Okay, so we have both the things in place. We have the code deploy agent running. We also have the npm in place. So we are good with the configuration of EC2 instance. We'll move to the third step. Now here exactly we start working with the AWS Ci Cd services. For that, what I'll do is I'll go back, I'll search for code build service here. So this is exactly falls under developer tools category. You see all these services. If I just close this thing, code commit, code artifact, code build, code deploy, code pipeline. More important, code commit as we understood, code build, code deploy, and code pipeline. Step 1, I'm going to create a project under code build. So as simple, you just move to the code build. I mean directly, if let's say you're using for the first time, you have to click on create project. Again, I'm giving the same name. The best option would be for the first time you follow the same name which I've given, and same I've added in the presentation. I've given the project name. You can leave all this open. Here, it's very important from a source perspective. Now, from a source perspective, you can GitHub, Bitbucket, GitHub. I mean, software as a one, or if you have your own setup of GitHub in enterprise, you can use that, or software code commit or S3. These are the all options when it comes to build. As someone asked me about GitHub, and as I said, I am going to use GitHub. So I've selected GitHub. There is public repository which are publicly available. So if someone really wants to focus, let's say, on these services rather than playing with the application, I will make this repository public, so you can directly point to my repository also. Or if you have any private repository, like when you're working on an actual live project, the repository will be private, it won't be public. So let's say if I have a private repository, then you have to select here. And here you can see all of my repositories which I've worked on, right? But I want to focus on Devops Ci Cd. This is my repository. And you can see here one important thing. This is for the one time you have to do. You are already connected to GitHub using OAuth. So let's say I disconnect this. Okay, and let me set up this OAuth again. As I said, it is very simple to integrate GitHub with code build. Either there are two options. Either I can take a personal token and do it, or using OAuth. I prefer OAuth. So connect to GitHub. choose confirm to connect Git build to your account. I'm already logged into my account of GitHub. I just have to say confirm. One second. I think it got stuck. Let me again do this. One minute. I think something is stuck here. Okay. I think so. Something is wrong. Let me do one thing. Let me stop sharing my screen and provide the token way of connecting it. But again, it's very simple that you have to just give it. I think there's something is wrong with. Okay. Yeah, you can see again it worked. Yeah. So as you can see, you have to just simply select and give it a code token, and here you are again connected. Maybe it was just stuck that particular screen. But yeah, this is how you have to connect it, and you can see again it's connected with auth token. Personal token and all, I don't prefer a way, because if the token get deleted or something, then that's a problem. But if you use auth, automatically that's been taken care, and then you can connect to all the repository or branch. So that becomes, you can do all other stuff, which will keep it optional for now, and we'll focus on the environment. Environment is what OS, like AWS code build will take care of deploying, let's say, whatever the platform, but what OS you want that platform, which operating version, that we need to provide. So either you can already provide your custom image also. If you have a very specific Docker build, you can provide that too. We will use AWS manage. I'll select Ubuntu. I'll select standard and 4.0. As simple, I'll just select the by default configuration which is provided and purely focus on understanding this service. You can either create a new service role or you can use the existing. I would say for the demo, use the existing one. This role is already deployed with help of the CloudFormation, the one we deployed. So here you can see there is a role deployed called as code build CI CD demo, the same one. And then you can have all those other stuff like VPCs and all. If you want to, if you have very secure code, sensitive code, and you want to put in a VPC, you can do all those kinds of stuff. I don't want to do it for now. Again, and then you can provide the build spec file here, or you can provide as an optional. Optional means that in your code repository. So if in my GitHub itself, you can see there is a build spec file here. So it will automatically pick it from that code repository. You can define the batch configuration, the artifacts. If you need to save that artifacts, like this artifact will be useful, as you can see here. If you have something like a Docker image, you generate a Docker image, and that's what you want to store in any sorts of Amazon Docker repository or Docker hub, that what is talk about the artifact. We don't have to worry about all those stuff. I will enable CloudWatch logs for a logging perspective. Checking this option will upload build output logs to CloudWatch. This is very important to troubleshoot. I'll click on create build. Any questions? Okay, so this is how you deploy the build. Next, if you go back to the presentation, this is what they have asked. Open console, create project, give the project name, set up the auth, select Ubuntu, and all the configuration what we have done. Also uncheck. If you remember at the last, I got an error and I unchecked the IAM role kind of thing, and then click on create button. That's about code build. Next, we talk about the code deploy. So now what I'll do is at the code deploy, I'll go back to this code deploy from here itself. And same, get started, create application, provide the name. The name can be anything. But as I said, I'll follow the standard for now. So CI CD demo. And then you have three options: EC2, Lambda, ECS. We have EC2 in place. So we select EC2. Again, as you can see, code deploy is also useful if you have any on-prem. If you have any on-prem server and there also you want to use code deploy, you can use, but do ensure code deploy will only work if you have agent running. That's why I have manually logged into that server with the session manager and I ensure that my code deploy agent is running. Most of the time people face an error because their code deploy agent get crashed or it's not working. That's why they get in failure error. So here we have created kind of a code deploy. And now I'll create a deployment group. Like deployment group is what platform? I mean, I've said, okay, it should be an EC2 type, but which EC2 instance? I cannot target all the EC2 instance in my account. So here I'll specify what is my deployment group, which are the set of resource or resources which I need to, which I want code deployed to work. So I'll give the name. And then the role, which I said, the same role which we have created via CloudFormation. There are deployment types. As I was talking about in the previous slides also, you can use in place, you can use blue-green. It's always recommended. I mean, since we're demoing it, in place is on the actual same server, you make the changes. The problem is if you make the changes in the actual same server, you will have a downtime. Downtime unless and until your entire deployment is done, no one will be able to access that application. Blue-green is like a different instance they do have, like a different replica instance. So the people can continue using it, and in parallel, another version of the platform will launch and there it will get changed. Where you can have things like auto scaling and all. But for demo purpose, since you guys are using it for the first time, let's keep it simple. Let's use in place. And in place, then you get an option as we selected in the beginning, EC2 / on-premise. So either you can target auto scaling or EC2 instance or on-premise. We will select EC2 instance. And then how to identify EC2 instance? Based on tags. So if you go back, if I, one second, let me do one thing. If you go back here in the EC2 instance, you have a name as key, and then you have to give a value for that, right? So from a value perspective, how you can get the value? You can go to EC2 instance and under running, you can see there is a tag here. This is a name, which is a key, and there is a value for it. Select this value and place this value under the CI/CD. That's it. And by default, when you place this, you will see that one unique instance, matched instance identifier. That means you have configured or code deploy has picked up your EC2 instance correctly from this means. Okay. Next, keep all those things as is. We have to define the load balancer. It's very important because code deploy is going to check whether your application is also running or not. It won't check whether your application is giving the right response, but at least it will hit the code application load balancer and see whether the application is up, not correctly running. Okay. So you will select this particular target group. Again, this is what we have deployed it from the CloudFormation itself, and then click on create deployment group. So that's about how you have been doing the code deploy part of it. Next, we will be doing here is we'll create the pipeline. As I was talking about the pipeline perspective, like the visual workflow. So we will be doing the pipeline now. And in order, as you understood so far, if you go and recap, we have done CloudFormation. We have configured the EC2 instance. We have done the code build, code deploy, and last we'll do the code pipeline. Now pipeline is just as I said in the beginning also, it is connecting all the dots. So whatever the things we have configured like the code build and code pipeline, Github repository, it will connect all those three things under one visual workflow. So I'll give the name. I'll select the role. The role I have already deployed via AWS CloudFormation. Next. Now this steps, as you can see, right? Step 1, pipeline setting. Step 2, code repository. Step 3, build. Step 4, deploy. And step 5, you review and say yes. So what we'll do the same thing. I will go here and I will say GitHub. As soon as I ask for the GitHub, it said, OK, can you connect the GitHub? Again, the same thing confirmed. Then it said, OK, can you just tell me which is the. So I selected my repository. This is my branch automatically. And this I was talking about change detection option. So as I said, there is a way where you can automatically trigger when there is a new change, which also I'll demonstrate, which you do it via GitHub hook. And you recommend that automatically when you make any changes in your GitHub repository in that particular branch, in that repository, pipeline will trigger automatically. So next, here we will provide, as I was talking about, you can do either Jenkins So if you, let's say, have your specific Jenkins server already on premise or somewhere and you want to use Jenkins, you can do that, or AWS code build. And we have already created the job or a particular build project. So we'll select the build project. It can be a single build or parallel build, like multiple trigger builds. We'll use a single build. Or you can even skip the jobs. There are certain times when you have like when you deploy a website, right? A static website on S3 with the pipeline, you don't need to build that. So you can skip the build job and you can directly deploy. So you have a GitHub or code commit and you can directly do the code deploy with help directly pointing to S3. You don't need the build job. So you can skip that. We'll do next. Here we'll do the same thing. There are multiple options available: config, CloudFormation, code deploy, Beanstalk, ECS, S3 and all, right? I was talking about S3 also. But what we'll do here is we will here select code deploy. And under code deploy, we'll give the name. This is the same name which we created the deploy job. Do remember that. The deployment group there, both we have given CI/CD-demo. That's why I was saying, very important. Don't try to change any sorts of name for the first time. Unless and until you understand how it works very much internally, then only try to make the changes. Next, again, if I go back, it always possible. Again, these are not very tightly coupled that you mean that you're doing the code pipeline. That means you need to deploy it. You can only stop at build job. You can skip this stage, or you can skip the build stage also, and you can only directly target to deploy. So it's very flexible from that perspective. There is no hard and fast rule that you need to have both build as well as deploy in the pipeline. So this is how we provided the pipeline settings, the source, your build, your deploy, and at the last we'll do a create pipeline. And as soon as we have done a pipeline, you'll see it started running the process. It will take a couple of few minutes to run the process, which will the same thing. It will clone the code. It will build the code. As you can see, the cloning is completed and it automatically selected the last commit of mine, which is adding CFT status, which was my last commit 2 hours back. And now it is working on the build. You can see from the details like, OK, which phase, what it is doing, the different environment files, if you have provided the build, resource utilization, all those kinds of detail you can look additionally here. Now it is provisioning. As you can see, it submitted the request got queued. Now it is provisioning the infrastructure where it can perform the build. And when you see the provisioning is done, you can see the logs coming out here, how exactly the build process is performing. Do you have, until this pipeline runs, do you have any questions about how this entire build process works? Any other questions on this demo so far? Or should I assume you guys, this is very good? Any questions?
No, sir.
OK, so let's wait for this build job to complete. So if I go back to the details, so as I was talking about, right, in the logs itself, you can see very clear how exactly it's building, what exactly, how the logs are in there and right. And now it says completed. That means it succeed. And if you go back to the pipeline, the build is succeed, source build succeed, and now it is deploying. So that means it is deploying it to EC2 instance. And if you see the view event, from the view event, you can see that, OK, these are the different phases it started. Now, by default, code deploy will have all these different phases, but we didn't configure the phases into our app spec, so it's going to skip. But if these are the all different events or life cycle code deploy performs on behalf of you. So you can use any of stuff like, OK, let's say if you have any live application, you can block the traffic. You can, after the block traffic, if you want to ensure that everything is successful, then you can stop the application, download and all. So this is the entire end-to-end very important life cycle which code deploy performs any different kinds of application where you're deploying it for the first time or you're deploying it for a live application. So, and again, this is all, the phases are optional, and this all phases we have configured via this app spec file. So if you see after install, application start, application stop, this all are the different events here. Okay. Now, if we go back to the pipeline, and if I open it up, you can see this succeed. Okay. You have a source, you have a build, and you have a deploy. So this pipeline got completed. How we can validate this got successfully deployed? So this was the link which previously was giving us 502, but now it started giving me the output UI. Now, this is a very simple demo which I've created, a celebrity recognition. What we'll do is we'll go to the desktop, let's say images, and let's say I upload the. Okay, the intent is not to understand the demo, or I mean this application. The intent is how this entire things works, right? So this is a very simple UI where I uploaded and all, and you get it previously, which was giving 502 before we run the pipeline. Let's say I make a small change. As I said, this pipeline worked for the first time. Now I'll make a small change in the pipeline and that will break the app. But the whole important thing to understand is not if the app is functioning or not, but how exactly the pipeline getting triggered. So what I'll do is I'll change the config file here and I'll make a change. As soon as I hit commit, okay, if you go back here, see automatically under pipeline, just now it started. As very fraction in real time, you will see as soon as I made a change, the pipeline got triggered and you can see changing the config for demo without me manually triggering it. So that's how the CI/CD works. For any change, the pipeline should trigger whether it's successful, whether it failed, but pipeline should trigger and it should pick up and continuously integrate. And it will perform the entire cycle again and release. So that's how you do continuous integration. Whenever I made a change, it continuously integrate and then it will continuously deploy. And again, you can have more sophisticated pipeline, like you can disable the transition from build to that build to deploy. You can have a manual approval here. Those additional configuration you can do from a best practice perspective. But this is how exactly the entire end-to-end work. I will take like few minutes this entire cycle works. And then you will see if I run the platform again, the platform will be up, but I made a small change and it will fail. It won't give me the output. So that's about the demo. If I go back on my presentation in the meantime, so we understood how the pipeline works. We have tested the application. We made some small changes and now we will be running the pipeline again. And we will see the output. But this is how you have to configure the entire pipeline or play around with the AWS CI/CD tool. Also, let's say if you don't want to use GitHub, GitLab and all, you want to use code commit way of doing it, then this is how you have to do. How to set up the code commit. I've given that instruction also. And it is very simple. From the drop down only you saw that where I selected GitHub, you have to give a code commit and you don't have to do auth and all because code commit is natively integrated with AWS IAM. So, but still you can use code commit also. You can use GitHub also. I focus on GitHub. You can leverage code commit also. So that's what we have from today's session. If I talk about starting, what we have done is a traditional way of understanding what DevOps is. Life without DevOps. You talk about how exactly from organization perspective people look DevOps, the framework, life cycle. In AWS fashion, this is exactly what we just performed, like how the cycle works. Different services of DevOps stack, which is required in AWS offering. We understood in detailed for continuous integration, continuous delivery. There are different services. There are code commit, code build, code pipeline. Infrastructure and automation, we do have services. Even for monitoring and security, we do have services. Platform, we have Lambda, Beanstalk, ECS. And most importantly, not from DevOps perspective, for developer or DevOps, candidate or employee perspective also, they provide Cloud Shell, they provide SDK, CLI. Right, and as I was talking about the Cloud Shell, I think I missed it. So if you want to enable the Cloud Shell, this icon is exactly what you need. And this is how in my browser itself, without logging, without doing any setup, By default in the browser itself, environment, a small workspace would be deployed via which I can perform any action, such as AWS CLI. I can write Python code. I can run anything without really doing any sorts of credential management or any sorts of infrastructure. So this is called as Cloud Shell, AWS Cloud Shell. CLI, I will just demonstrate it once this entire system is up, but it's exactly as simple as how it is given in this screenshot. Okay, it's up. So AWS CLI, and you can see there are all the different services it has been given. And let's say if I fire for one of the services, AWS S3 LS. Now, I don't know any programming language. I'm not a programmer, but I know the commands. And with help of simple command with CLI commands, I can easily get all the outcomes here. Like it's listing the bucket. It lists down all the buckets in my account. So that's how CLI is very powerful for the people who are not having programming background and all. And if you want to understand in detail, you can refer to this hyperlink. And then we look into the demo where we set up the entire cloud formation, the EC2 instance, code build, code deploy, the entire pipeline. We did a small check. Now I think the pipeline should be done. Yes, you can see the pipeline is done successfully after the change in the GitHub automatically, right? And if I do the same thing, if I refresh this application, let's say, this is exactly what we have made the change. No config file available. Please add a config file. So that's how generally the entire pipeline works in a single click, where you can not only for successful build, even for failed build also, don't worry about it. You should use the pipeline actively because that will help you to test your application in real time, integrate, test your application and release. At the last, if you want to use code commit instead of GitHub, then these are the steps for doing that too. And that's all we have from today's session, as well as from this 3-session DevOps, getting started on DevOps and overview around it, where we started our journey with AWS serverless in the first session. Second session, we understood all the cloud formation and infrastructure as a code. And in today's session, we understood why DevOps, what DevOps, how serverless cloud formation works hand in hand along with CI CD services. That's what you need to start your journey in DevOps. There is many other learning path, complex scenario that you have to practice. But to start your journey, the foundation perspective, this is more than suffice material. I will put all the materials into code repository and I'll share the link with Mayur. Post the session, please follow up with Mayur, and you can try this session at your end and let me know if you have any questions and queries. So that's all from today's session. If you have any questions now, please let me know if you have any questions.
Hello.
Hello.
Sanjit sir.
Yeah, please go ahead. I'm listening to you.
Yeah, sir. So basically, I'm using AWS Lambda. Like I have a Node application and I want to host a website on AWS Lambda. So I'm not finding any proper documentations for that. Like I know I have to use API gateways or some stuff, but like where should I properly look for to host my Node application on Lambda?
So by default in the developer kit, so I'll tell you the very first documentation, which is you should always look forward, is the Lambda developer guide. In the developer guide, AWS itself has a Node.js blueprint. Right? If you follow that Node.js blueprint and try to deploy your application, there you can look into that perspective. That's one way of Node.js developer. That's around one aspect to do it. Second, let's say if you have a very complex specific application and you're trying to do, then you can even containerize that application and put it into Docker. But if you want to start that around it, you can use the developer guide of Lambda, which will help you to resolve that issue. They have very extensive documentation around Lambda.
Okay, sir.